In part A of this question, we're asked to find the reactions at P and Q. I've started by putting in RP and RQ on the diagram, but we also have the mass of this uniform rod of 9 kilograms, so that would be 9g, acting at 1.5 meters from A, which is the center point of this uniform rod. It's 3 meters long. We have 2 kilograms acting at A, so that would be 2g acting at A. And we're also given that A to P is 1.2 meters and A to Q is 2.6 meters, and the system is in equilibrium. In the first instance, the best thing would be to resolve vertically. Taking upwards as positive, we can see that RP plus RQ is equal to 2g plus 9g. So RP plus RQ is equal to 11g. One equation, two unknowns, so we need to find another equation, and the way to do that would be to take moments, and the obvious thing to do here would be to take it around a reaction point, so I'm going to take moments around P. Before we start, let's just work out in which direction these weights and reactions are acting. So we can see the 9g is acting clockwise. If we were stood at P, the reaction at Q is acting anti-clockwise, and behind us, if we were stood at P, the 2g is also acting anti-clockwise. So clockwise moments will equal the anti-clockwise moments if we're in equilibrium. So we can see that the 9g multiplied by 0.3, which is the distance from P to where the weight acts at the centre, 1.5 minus 1.2, is equal to RQ multiplied by 1.4. This is calculated by taking the distance A to Q away from the distance A to P, plus 1.2 times 2g. That's the distance from P to A, where the 2g is acting. Rearranging, we can see that RQ is equal to 9g multiplied by 0.3 minus 1.2 times 2g all over 1.4. Substituting into a calculator, you should find that RQ is 2.1 newtons. Now we have RQ, we can substitute that straight into our first equation. RP plus RQ, which is now 2.1, is equal to 11g. And we can see that RP is equal to 11g, subtract 2.1. The reaction at P is equal to 105.7 newtons.